Hey guys, welcome to our video on the combined gas law. Here we're actually combining three of the gas laws that we've already learned about. So you'll need your notes, which is your pen and paper, your calculator, Table A, which I've actually shown here for you, and Table T. You'll also need your Unit 3, Section 2 packet. So just kind of remind you with Table A, if they ever talk about STP, that is just your standard temperature and pressure. So STP, that's your standard temperature and pressure, and that can be found on Table A. So your overview is what is the combined gas law. You're going to rearrange some equations and do some examples. So let's talk about the combined gas law. Well, first, let's talk about the three gas laws that we've already done. We know we have Charles' law, that's V1 over T1 is equal to V2 over T2. We also have Boyle's law, which is P1 V1 is equal to P2 V2. And then we have Gay-Lussac's law, which is P1 over T1 is equal to P2 T2. When you combine all three of these, or look at all three of them together, you notice that we actually can merge them together. So I have V times P over T, and then V2 times P2 over T2. So when we see this, it's P1 V1 over T1 is equal to P2 V2 over T2. The nice thing is that you'll never have to memorize this. This is actually located in Table T for you. So it's called the combined gas law. And in fact, you actually don't even need to memorize any of the other gas law equations. You need to know the concepts, of course. But the formulas are actually kind of here for you. So for example, if I had constant volume, I can put a 1 in for each of the volumes. And then it would just be P1 over T1 is equal to P2 over T2, which is your Gay-Lussac's law. If I had a constant temperature, meaning the temperature didn't change, I would have P1 times V1 equals P2 times V2, which is actually just going to be your Boyle's law. And then let's do the last one. If I have constant pressure, meaning my pressure doesn't change, I can have V1 over T1 is equal to V2 over T2, which actually ended up being Charles' law. So the nice thing is that you can actually use the combined gas law to figure out what everything else is. Just a word of wisdom, in case you didn't realize this, don't put in a 0 for the things that you're trying to keep constant, because if you had, say for example, if you had 0 times V1, the whole thing would be 0, and that would be wrong. So if you can either just cover up the P1 V, and P2, or you can just put 1 in its place. So let's talk about rearranging these equations. You will need to rearrange the equations, and you've done this before. It's not anything different, it just has different letters. So you've done this in math class. It's not a big deal, you can handle this. So say for example, I want to get P1 all by itself. I need to make sure I can isolate P1. So essentially what I'm doing is dividing both sides by V1 and multiplying both sides by T1. So I'm taking the reciprocal of whatever's left over. So I'm taking T1 over V1, and just to prove that, I'm canceling out V1 over here and canceling out T1 over here. So on the left hand side, I'm just left with P1. So P1 is equal to P2 times V2 over T1 over T2 times V1. Right? So that's how I would rearrange the equation if I had to isolate P1. If I need to isolate V1, I would do the same thing. I would just take the reciprocal of whatever's left over here, so T1 over P1, and then do the same thing on both sides, T1 over P1. So I cancel out the T1s, cancel out the P1s, and then I'm left with just V1 is equal to P2 V2 times T1 over T2 times P1. And I've talked to your math teachers, you've seen this before, so if it actually helps you out, you could also just, so say for example you want to isolate V1, take P1, move it down there, take T1, move it up there. Okay? So let's take a look if we wanted to isolate T1. I know that T1 is in the bottom here, I want it in the top. So I'm actually just going to move my T1 to both sides. And you can put it over 1 if that makes you more comfortable. So I'm actually getting rid of T1 over here and putting it in the numerator over here. So that leaves me with P1 V1 over 1 is equal to P2, V2, T2 times T1. So if I want to get, again, T1 by itself, I just multiply the reciprocal of whatever is next to it. So T2, P2, V2, and then do the same thing to both sides. So T2, P2, V2. Cancel those two, cancel those two. There we go. So what I'm left over with is T1 over here. So T2 times P1 times V1 over P2, V2. Okay. And I know some of you guys have seen before where you can just kind of flip-flop them. So this would get moved there, that would get moved down there, and then flip-flop. That's fine too. Kind of move things around as you need to, all right? Just practice rearranging your equations. So let's do some examples, and you have this in your handouts as well. The biggest thing I want you to look out for is making sure that your temperature is in Kelvin and that your pressure and volume units are all going to be equal to or the same. So if your P1 is an ATM, make sure your P2 is an ATM. So a gas has a constant volume of 800 milliliters at negative 23.0 degrees Celsius and 300.0 torr. What would the volume of the gas be at 227 degrees Celsius and 600 torr? So what's given here on the left-hand side, or the first sentence, are all your 1 values. So milliliter is a volume, so that's volume 1. Celsius is a temperature, that's T1. And torr is a pressure, that's P1. Next I have Celsius over here. So the conditions have changed. I'm now making this T2 and this is P2. So just like you had before, go ahead and put in those values. I'm actually going to leave myself a little bit of space here. So your P1 is 300.0 torr. Your V1 is given as 800.0 milliliters. And your T1 is negative 23.00 degrees Celsius. When you plug this into the equation, K is equal to 273 plus your degrees Celsius. It's 273, essentially minus, but we'll do plus a minus 23, or negative 23. So from there you should get 250 decimal Kelvin. Okay, so make sure you have that. I'm going to clear out those in just a bit, just so we have enough space for all of our other work. Okay. So I'm going to get rid of that real quick. Okay, let's go to your P2. So we know that that's our P2. It's 600.0 torr. Hey, look, our pressures are the same unit. That's nice. The question asked what would the volume be, so your volume is your unknown. And let's keep that in the same unit as what your V1 was. Your T2 is 227.0 degrees Celsius, so we'll plug that in again. So we had 273 plus the Celsius, so 273 plus 227.0 degrees Celsius. So go ahead and add those up. We actually end up having 500 Kelvin. Make sure that decimal point is there as well. And I'm going to erase this just so I have enough room for all my other stuff I need to do. So I have values for P1, V1, T1, P2, and T2. V2 is my unknown. So let's take our formula. Try to figure out where I have the most amount of space. So P1, V1 over T1 is equal to P2, V2 over T2. So I want to isolate my V2. I'm just going to multiply T2 over P2 by both sides. Okay. So that way this cancels and this cancels. And I'm kind of like when my variable, my unknown, is on the left-hand side. So I'm just going to switch them. That's fine. T2 times P1 times V1. And that's multiply is over P2 times your T1. So let's plug in our values. And I'm going to do this up here. My V2 is equal to my T2, and this is when it's really helpful to write out all those numbers over there. on the left-hand side. So 500K times my P1, which is 300.0 torr, and I don't have enough space, I'm going to try to squeeze it in. My V1 is 800 milliliters. And that is all over my P2, which is my 600.0 torr, times T1, which is 250 Kelvin. Alright, let's cancel some units. Let's get rid of some stuff so it makes it a little bit easier on ourselves. Kelvin, Kelvin, and torr, torr. I'm left with milliliters on the top, and that's a good thing because I want volume at the end. So, plug this into your calculator. It's 500 times 300 times 800. Press the equal sign, and divide this. But make sure you use your parentheses. Your parentheses are it's a really useful tool in your calculator. So, you have 500 times 300 times 800 equals, then divided by, take an open parenthesis, and do 600 times 250, then close out your parenthesis and press enter. So from there, we actually end up getting 800 milliliters. And I just put in that decimal just to show you sig figs. So this has 3 sig figs, this has 4, this has 4, 4, and 3, because that dot was there. So we want to use the least number of sig figs when we multiply and divide, hence why I have 3 sig figs here. Put a box around your final answer so I know where it is. Right? So we want to make sure that this makes sense. We had a change in pressure and temperature, but our volume ended up not changing. We could plug this right back in just to make sure it makes sense as well. Okay. I'm running out of battery power, of course. Alright, so a gas has a volume of 800 milliliters at negative 23.00. Oops, let's see. Who did that one? Okay. Oops, sorry, darlings. Oh, yep, okay. Number 2 is pretty similar, so we're going to go to number 3. What is the final temperature of a 400 ml gas sample? So already they tell us what is the final temperature. We want to know what T2 is. Of a 400 milliliter gas sample that has an initial temperature of 22.0 degrees Celsius and a pressure of 2.3 atm, when the pressure changes to 4.5 atm. So let's make sure that we know what everything is. So we have the final temperature, and we want to know what the final temperature is, so that's our unknown. We know that's in Kelvin because it's temperature. It's 400 milliliter gas sample, and this is in volume, so we actually don't have another volume unit, so the volume is actually constant. It's the same thing on both sides. So we can actually rearrange this. When we rearrange this, we can make this a little bit easier. The initial temperature, so that automatically tells me T1 is 22 degrees Celsius. That ends up converting to 295 Kelvin. So the initial temperature and the initial pressure of 2.3 atm. And it says here the pressure changed to 4.5 atm. So I now have P1 V1 over T1 is equal to P2 V2 over T2. I knew my volume didn't change, so you know what? Let me just get rid of it. I can cancel that out. Pretend like it's 1, or I haven't even put it in there. So I have P1 over T1 is equal to P2 over T2. This ends up being Gay-Lussac's law. I know I'm trying to figure out what the T2 is, so I'm going to rearrange my equation. And whenever I have something in the denominator, I just want the numerator on the other side. That's fine. Okay, so I have T2, P1, T1 is equal to P2 over 1. My T1 or my T2 is still not all by itself yet, so I'm going to multiply it by T1, P1. Do the same thing to both sides. Cancel, 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 cancel. So my T2 is equal to P2 times T1 over P1. Alright, then just plug in your values. My P2 was 4.5 atm. My T1 is 295 Kelvin. And then my P1 was 2.3 ATM. Let's take a look at sig figs real quick. I have 2 here, 3 here, and 2 here. So my final answer will be in 2 sig figs. So it's 4.5 times 295 divided by 2.3. So go ahead and do this. I end up with around like 577. But I know I only want 2 sig figs because of this one right here. So I'm going to go 1, 2. This 7 is going to round up that 7 over there, so it ends up being 580. And my units should be in temperature, good, because I've canceled those. And I don't want a decimal place after that 0 because I know I only want to have 2 sig figs. Alright, good to go. So here, number 4, at conditions of 785.0 torr and 15.0 degrees Celsius, a gas occupies a volume of 45.5 milliliters. What will the volume of this gas be at standard conditions? So let's highlight some information. I have 785 torr. Since it's torr, I know that that's going to be pressure. I'll make that P1. And 15 degrees Celsius, that's going to be T1. We have a volume, which is right there, 45.5, that's my V1. And what will the new volume, so this is my unknown or my X, or my V2, at standard conditions. So I have standard conditions there. Recall that standard conditions means STP. Go back to table A. So I'm going to give myself a little bit of space here just to write these values in. My P1 is 785 torr. Just want to make sure that's in there. Sorry. Oh, there we go. Sorry, I had just to make sure I saw that. 785.0 torr. T1 was 15 degrees Celsius, so 15 degrees Celsius actually ends up being 288 Kelvin. My V1 is 45.5 milliliters. Now I have P2 and T2. I know I want standard conditions, so my T2 will be 273 Kelvin. I'm not going to pick degrees Celsius because we don't do degrees Celsius here. I'm going to pick 1 ATM. I know I have a choice between ATM or KPA. I'm just going to do ATM here. So the temperature is 285 Kelvin. Okay. Your P2 will be 1 ATM. Your V2 is X, or your unknown. Your T2 is 273 Kelvin. And your V1, go back to that one, sorry, 45.5 milliliters. So here we see that the pressures are 2 different units, so we have to be able to convert them into 1 unit. We're going to stick with ATM, so we have, we'll do it over here, 785.0 torr over 1, and we'll convert that over to ATM, so 1 ATM over 760 torr. When we do that, we end up having 1.03 ATM. So we'll use that instead of the 785 torr. I'll actually even erase that for sake of room. There we go. So we will convert the units, or sorry, not convert the units. We'll go ahead and solve for V2. So we know that V2 is equal to P1, V1, T2 over T1 times P2. So we'll put in all of our numbers, 1.03 ATM times 45.5 milliliters for P1. T2 is 273 Kelvin. Okay. T1 is 288 Kelvin. It's supposed to be an 8, sorry guys. And then we need P2, which is 1 ATM. We'll go ahead and cancel out any units that we have, and then solve for V2. Go ahead and punch this into your calculator. Okay, so we need to make sure that we have 3 sig figs, so we end up with 44.4 milliliters. Right. Oops, sorry about that, darlings. Okay, so to summarize, we need to rearrange our equations. Sorry, there we go. Okay, so if they ever ask for STP, we use standard conditions, 1 ATM and 273 Kelvin. We need to remember how to rearrange all of our equations and make sure that we watch for different units. So I might give you different units for pressure, for example, so be able to convert between the two. If you have any questions, let me know. Take care.